In section 2.6b, I want you to be able to write the rule for a transformed function, perform transformations and graph them, and solve problems involving linear transformations. So we're going to start out writing rules for transformed linear functions given a table. You're going to use the linear function defined in the table and reflect it across the y-axis. So here is our table. And before we can reflect it, we have to write a function. And the function we're going to get by first finding the slope and then the y-intercept. Okay, so if we find the slope, I'm going to use the first 2 points here. So y goes in the numerator, 2 minus 1 over 0 minus a negative 1. So that's going to be 1 over 1. So our slope is going to be 1. And we can actually look at the table here, and because x is 0, this is our y-intercept. And you could do the work if you want to, but if you notice that that's the y-intercept, you don't have to do anything. You can just put 2 down here. Now, we're going to write the equation for the line. If our slope is 1 and our y-intercept is 2, we just have f of x equals x plus 2. Now, I want to reflect it over the y-axis, which means I'm taking the opposite of just the x. So the way we can show that is put parentheses just around the x, and then show that we're taking the opposite of the x. And then if you simplify, just take the parentheses away. Now, you might say, well, why are you putting parentheses there? Why don't you just jump to this step? When you get into the quadratics and the cubics and the square roots, you'll want to make sure you put parentheses there so you square the entire thing. So I'm just going to be consistent and do that right from the start with the linear functions. All right, we're going to graph transformations of linear functions. First, we're going to do a vertical compression by a factor of 1/4 to this function. Now, when we say vertical, that means the entire right side is being affected. So to start off, we're going to put the function in parentheses. Compression means to multiply, and we have a factor of 1/4. And now I'm going to distribute. So I have 3 over 4x and then 2 over 4, and that just is going to simplify to g of x equals 3 over 4x plus 1/2. So my slope is 3/4. My y-intercept is 1/2. And it says graph the original function in a solid and the transform function with a dashed line on the same coordinate plane. And I've already graphed the original function. The original function crossed the y-axis at 2. And it had a slope of 3, so I went up 1, 2, 3 over 1, and I went in the other direction, 1, 2, 3, and then to the left 1. That gives me this pink line here. And now I'm going to graph the transform function. I put the y-intercept on here already, which is 1/2, and then my slope is 3, so 3/4. So 1, 2, 3, and over 1, 2, 3, 4. And then I can graph that one with a dashed line. And it should look like our function has been compressed vertically. So if you do this again, remember when we first started doing functions or transformations, I told you to think of your hands. And vertical means the y-axis. Compression means we're pushing it. So it does look like this would slide down like this and be compressed as we went along the y-axis. All right, something else you're going to have to do is to solve problems involving linear functions. And here is a problem that the dance club is selling t-shirts as a fundraiser. Club paid $75 for the material, and they are selling the t-shirts for $12.50. This is going to be your flat fee. They're only going to pay that one time, but depending on how many t-shirts they have, this will change. So, or how many t-shirts they sell. So we're going to put the X next to the $12.50. If we sell one t-shirt, it's $12.50. If we sell 2, it's $25, and so on. Okay, now, if they decide to double the price of the t-shirts, this is what's going to get doubled. This is not going to be doubled because that's the price for the material. So we're only going to multiply the price of the t-shirt by 2, and that's going to leave us with g of x equals 25x plus 75. Okay, on the side over here, It has you graphing. I'm not going to have you do that. You'll do some of that in your homework assignment. So you can just put an X through that. And then when you get to your questions on the other side here, you can also put an X here for the graph of the original function.